Imagine a little spacecraft way out there, billions of miles,
Hmm.
trying to figure out like what's going on with these other planets.
A long, lonely journey, pushing the limits of everything we know.
Welcome to Cosmos in a Pod, our space and astronomy series. So today we're heading out, way out past Mars, to those gas giants, Jupiter, Saturn, Uranus, Neptune, the whole gang. What makes these places so interesting, and how do we even send stuff out there to look around?
Well, it's a story of, ambition and this human need to know what's out there.
Okay, so first off, why bother? They're so far away and so different. What makes them worth the effort?
Well, it's more than just their size, right? They're like time capsules from way back, like when the solar system was just starting.
So by setting them, we're kind of looking back at how our planet got started too.
Yeah, exactly. They can tell us about how planets form, where different elements ended up, maybe even like the conditions for life way back then.
That's fascinating. But it's not all about the past, right? There's this whole question of if there's life out there somewhere else.
Oh, for sure. And some of the moons around those gas giants, places like Europa and Enceladus, have scientists really excited.
Oh, yeah, I've heard of those. What makes them so special?
Well, we think they might have these huge oceans, like hidden under the ice. And you know what they say about water?
Yeah, where there's water, there could be life. Imagine that. Alien life right here in our solar system.
Exactly. It's a huge motivator. Those oceans could have like whole ecosystems we've never seen before.
That would be amazing. But let's be real, getting out there is a challenge. We're talking billions of miles.
Oh, it's a huge effort, that's for sure. Big rockets, precise calculations, and a little bit of, well, cosmic trickery.
Cosmic trickery, now that sounds interesting.
Think of it like a slingshot, but with planets, you use the gravity of a planet like Earth or maybe Venus to get a speed boost towards your target. Saves fuel, too.
Like using the solar system as a highway.
Exactly. Voyager 2, on its way to Neptune, did that. It got a boost from Jupiter, then Saturn, then Uranus.
Pretty clever, yeah. But even with those boosts, we're talking years, right? Decades even.
That's the thing with space. Cassini took 7 years to reach Saturn, and Voyager 1, 2 years to Jupiter. It's a long game.
Wow, that's dedication. But once they're out there, how do they stay powered up? It's got to be pretty dark and cold that far out.
Well, that's where the ingenuity comes in. They use something called RTGs, radioisotope thermoelectric generators.
Okay, RTGs, huh? What exactly are those?
It's basically a tiny nuclear power plant using the heat from plutonium decay to make electricity. It lets them run for years, even decades, out in the cold and dark.
Wow, pretty impressive. But what about staying in touch? How do they talk to us over such vast distances?
Communication is key, of course. It all comes down to, technology and patience. The probes have these big antennas to send signals back to Earth, to NASA's Deep Space Network.
Oh, so like giant ears listening for these tiny whispers from across the solar system.
Yeah, something like that. But even at the speed of light, those signals can take hours. Imagine waiting 4 hours for a message from Neptune.
I can't even imagine. Speaking of messages, what kind of tools do these probes have to learn about all this stuff?
Well, they're like flying labs, really, packed with all sorts of instruments.
Like what?
Well, you gotta have cameras, right? They capture those amazing pictures of planets, rings, moons, surfaces, weather, hints about what's inside.
Like a cosmic paparazzi, but for science.
Hmm. Yeah, but the pictures are just the start. Those images give scientists tons of data.
So what else do they have?
They use spectrometers. Those are like detectives. They figure out what atmospheres and surfaces are made of.
So like fingerprint analysts, but for planets.
Yeah, that's a good way to put it. For example, because of spectrometers, we know that Titan has a methane atmosphere, and Europa's surface is mostly water ice.
Amazing. Anything else?
Magnetometers. They measure magnetic fields, and that tells us about the inside of a planet, like what's going on in its core and how it interacts with solar wind.
So probing those like invisible forces that shape the planets.
Exactly. And then there's radar, super important for those icy moons.
Why is radar so good for icy moons?
Because it can see through the ice, so we can map what's underneath, like those possible oceans on Europa and Enceladus.
Like X-ray vision for icy worlds.
Yeah.
That's incredible. All those instruments working together to help us understand these planets.
A symphony of science and tech.
Now, let's talk about some of the stars of the show, those famous missions that have made these discoveries. What are some of the biggest names and what did they find?
Well, the history of exploring the outer solar system is full of pioneers, each mission building on what came before it.
Let's start at the beginning. Who are the first ones to get out there?
The first ones were Pioneer 10 and 11 back in the early 70s. The first to really check out Jupiter and Saturn.
Right.
They paved the way for everything that followed.
Like the Lewis and Clark of the outer solar system.
Yeah, I like that. There were so many unknowns back then, but they got the data and showed it could be done.
What about Voyager? Those are some of the most famous, right?
Oh, definitely. Voyager 1 and 2. Launched in 1977, they went on what we call the Grand Tour, visiting Jupiter, Saturn, Uranus, and Neptune.
Wow, what a road trip. What did they find out there?
Well, Voyager 1 got the first good images of Jupiter's Great Red Spot, showing how wild and turbulent it is.
I remember those images. Pretty mind-blowing.
And Voyager 2 got to Saturn and saw all these intricate structures in the rings, including those little shepherd moons that help keep them in shape.
Crazy that something so small can control something so big.
It really shows you how delicate the balance is out there. Oh, and let's not forget Voyager 2 going past Neptune and finding 6 new moons, plus that planet's wild atmosphere with its own big storm, like the Great Red Spot, but dark.
That's amazing. So many discoveries. But what about missions to just one planet, like Jupiter?
Right, well, there was Galileo, orbited Jupiter from 1995 to 2003. It taught us a lot about the planet and its moons.
Like what?
Well, it actually saw a comet hit Jupiter, Comet Shoemaker-Levy 9, back in '94. Got to see all those pieces crashing into the atmosphere.
Ah, wow, that must have been something else.
It was a big deal for scientists figuring out what Jupiter's atmosphere is made of and how those impacts work.
Incredible. Anything else?
Yeah, maybe the biggest discovery was that there's probably a saltwater ocean under the ice on Europa.
Adding to the idea that there might be life there?
Exactly. And Galileo also studied Jupiter's magnetic field and how it messes with the moons, giving us a much clearer picture of the whole Jovian system.
That's fascinating. So we've got Pioneer, Voyager, and Galileo. Any other standout missions?
Oh, absolutely. We can't forget Cassini-Huygens, which spent 13 years from 2004 to 2017 checking out Saturn and its moons.
Oh, yeah, Cassini. Those were some incredible pictures of Saturn's rings.
Oh, yeah. Cassini showed just how complex and dynamic those rings are, constantly changing with little moonlets embedded in them, making waves and gaps.
Like a cosmic dance, with the rings and moons moving together.
I love that. But Cassini was about more than just the rings. It carried that Huygens probe, the one that landed on Titan in 2005.
Wait, we landed something on Titan.
Yeah, a big moment. Huygens sent back the first pictures from the surface, and guess what? Rivers, lakes, even seas?
No way. That sounds kind of like Earth.
Right. But there's a twist. They're not water.
Whoa, okay. Then what are they?
Liquid methane and ethane. Titan's so cold that those things are liquid. Imagine rain made of methane.
Wild. So Titan's got its own weather cycle, but with methane instead of water.
Exactly. And Cassini also found something amazing at Enceladus, another of Saturn's moons.
Didn't we say earlier that Enceladus might have life?
Right. Well, Cassini saw plumes of water vapor shooting out from Enceladus's south pole, suggesting a big ocean under the ice.
Wow, so even more evidence for those hidden oceans. Incredible.
And those plumes have organic molecules, the stuff life's made of. So the idea that Enceladus could have life gets even stronger.
That's awesome. So there are all these missions like Voyager and Cassini. What about anything going on right now?
Well, there's Juno orbiting Jupiter. Got there in 2016.
What's Juno doing up there?
It's all about Jupiter's atmosphere, its magnetic field, and what's going on inside. It's already shown that the storms on Jupiter, like that Great Red Spot, go really deep.
So it's giving us a 3D view of Jupiter's weather.
Kind of. And it's also telling us about how the planet formed, how it changed over time, and, its role in making the solar system what it is.
Sounds like we're just getting started with what we can learn from these planets.
Oh, definitely.
Yeah.
So much more to uncover. Yeah, it really feels like the more we learn, the more we realize how much is still out there.
Like peeling back layers of an onion, right? You just find more layers.
Huh, yeah, cosmic onion. But before we get totally lost in all that, let's focus on some of the coolest stuff out there. Those moons and rings, they're pretty amazing.
Oh, for sure. They're like little solar systems all on their own.
And they might hold the keys to figuring out if we're alone in the universe.
Let's start with those icy moons. We keep coming back to Europa and Enceladus. What makes them so special?
Well, we talked about it earlier, but they probably have these huge oceans under all that ice. And, water's pretty important for life, at least the kind we know.
So those oceans could be full of aliens. I mean, it's a cool thought, but how could anything live down there? It's got to be freezing and dark.
Well, that's the big question, right? But those oceans are probably salty, like ours. And they might have those organic molecules, the building blocks for life.
But how could anything survive under miles of ice?
Okay, well, that's where things get interesting. That ice is like a shield, protecting the ocean from the cold and radiation from space. Plus, there might be hydrothermal vents on the ocean floor, like the ones we have here on Earth. Those could provide the heat and energy for life to get a foothold.
So imagine these hidden places, teeming with life, tucked away under all that ice. It's like science fiction.
I know, right? And the evidence is pretty strong. We've seen those plumes of water vapor shooting out of Enceladus, and we've measured Europa's magnetic field changing, which hints at a salty ocean beneath.
It's amazing to think that these, seemingly barren balls of ice could be hiding so much.
Yeah, and it's not just those two. There's Ganymede, Callisto, Titan. So many icy moons out there that we need to explore more.
So many places that could have life. Mind-blowing. But what about those rings? Saturn's rings are like the most famous.
Oh, yeah, they're iconic. A real symbol of how beautiful space can be. So vast and intricate, constantly shifting. A real dance of ice and rock.
So what are they actually made of? Are they like solid?
Not at all. Think of it as like countless pieces of ice and rock all orbiting Saturn together. Some are tiny, like dust grains. Others are huge, like house size.
So like a giant disco ball, but with ice and rock instead of glitter.
Yeah. But the cool thing is, they're not just pretty. They actually change and move because of the gravity from Saturn's moons.
Wait, the moons affect the rings?
Yeah, some of them, we call them shepherd moons, orbit really close to the rings or even inside them. And their gravity keeps the ring particles in line, creating gaps, waves, even grades.
It's like the moons are choreographing this giant cosmic ballet.
That's a great way to put it. And Cassini, remember that mission? Well, it showed us that the rings are even more complex and active than we thought. We even saw moonlets forming within the rings, making these like propeller shapes as they plow through the ice particles.
Incredible that something so small can have that much impact.
Right. Even in the vastness of space, small things can make a big difference.
Speaking of small, what about Pluto? I know it's not a planet anymore, but New Horizons, that probe that flew by in 2015, showed us some pretty amazing things.
Oh, yeah. Pluto is way more interesting than anyone expected. For one, it's got this huge glacier made of nitrogen ice shaped like a heart.
A heart? Really? That's pretty cute for such a distant world.
Yeah, they call it Tombaugh Regio, after Clyde Tombaugh, the guy who discovered Pluto. But there's more to it than just the heart.
Like what?
Well, there are huge mountains made of water ice, some of them as tall as the Rockies, and these vast plains of nitrogen ice that move like glaciers. It even has a thin atmosphere, mostly nitrogen, with this blue haze.
So Pluto's not a dead world at all, huh? Pretty active and diverse, actually.
Exactly. It blew away all our old ideas about it, showed us that even way out there on the edge of the solar system, there are worlds full of surprises.
It seems like every time we send something out there, we get more questions than answers.
And that's what makes it so exciting. It's all about pushing the boundaries of what we know and seeing what's out there.
It's amazing, thinking about all these missions going so far. But it's got to be risky, right? Sending all this delicate equipment to, like, the harshest places imaginable.
Oh, yeah. Space exploration is always a challenge, especially when you're talking about the outer solar system.
What are some of the, biggest challenges they face? What do they worry about the most?
Well, first, you got to get off the ground right. Launching one of those probes, it's a huge operation. So many things got to go exactly right.
Like a giant machine with no room for mistakes.
Exactly. And even once you're up there, in space, anything can happen. Equipment could break, communications could fail, you could run into space junk. It's a constant fight against, well, the universe itself.
So it takes a lot of planning and some luck too, I guess.
You got it. But even with the best planning, there are always things you can't predict. It's high risk, high reward.
And when something does go wrong, it must be tough on the teams that have worked so hard for so long.
Oh, absolutely. These missions, they represent so much. People's dreams, years of work, so much dedication. But even when there are setbacks, there's always that drive to learn from it and do better next time.
It's that, I guess, that human spirit that keeps us exploring, right?
Yeah, for sure. And speaking of the human side of things, it's important to remember the passion behind all this. It's not just about the science, It's about the people.
Yeah, what makes people want to dedicate their lives to this? Exploring places they might never even get to see with their own eyes.
Well, for a lot of them, it's that curiosity, wanting to figure out our place in all of this, pushing the limits of what we know, contributing to something bigger.
Leaving their mark,
That's part of it. But it's also about, working together. These missions, all kinds of people together, scientists, engineers, technicians, all working towards a common goal.
Like each person bringing their piece of the puzzle to make this amazing picture.
Exactly. And when there's a big discovery, those first pictures from a new world or finding proof of a hidden ocean, everyone gets to celebrate.
It must be an incredible feeling, knowing you were part of something so important.
Pure joy. You're part of history, expanding our understanding of the universe.
You've really shown us all the excitement and challenges and triumphs of exploring the outer solar system. A real journey of discovery.
It's been great talking about it with you.
Before we go, I want to leave our listeners with one thought. As we explore further, it's not just about getting to new places. It's about understanding where we fit in all of this, and inspiring others to keep exploring.
We owe a lot to the people who came before us, They dared to dream about these other worlds. And it's up to us to continue that, to keep learning and keep that spirit of exploration alive for the future.
That's a great point. Well, that wraps up our deep dive into the outer planets. Don't forget to follow and subscribe to Cosmos in a Pod for more space adventures. And check out our YouTube channel for amazing videos. Until next time, keep looking up.